Hey guys, today we are going to be solving compound inequalities. When we're doing this, we're going to solve each piece individually and then graph our final solution. So solving is kind of similar to when you graph, where if you remember from yesterday, I graphed one piece, then I graphed the other piece, and then I saw what was happening. So here we're going to solve one piece, then we're going to solve our other piece, and then we're going to see what's happening. So the first thing I want you to do is kind of mentally cover up, or if you do have a sticky note, I have one right here, you can actually cover up that other piece so that you can't really see it and just focus on this one. So I've got 2x minus 5 is greater than -1. Okay, I'm going to solve this just like we did on Monday and Tuesday. So I'm going to add 5 to both sides. They cancel on the left, so I get 2x is greater than 4. I'm going to divide both sides by 2, and I get x is greater than 2. So there we go. Solved the first one. We're good to go. Now I can take this off. I'm going to bring my joining word down, and now I'm going to solve the other one completely on its own. It is its own inequality. So I'm going to subtract 3 from both sides. They cancel on the left, and I'm left with 4x is less than or equal to -4. Then I'm going to divide both sides by 4. They cancel on the left, and I get x is less than or equal to -1. So my final compound inequality is this guy right here. X is greater than 2, or x is less than or equal to -1. So now I can write out my number line, which it doesn't even need to be as big as I just made it, and I'm going to graph these. So I'm going to put 0 in the middle here, and then I'm going to put 1 and 2 on the right, and then -1 and -2 on the left. And we can go ahead and graph these. I'm going to use a different color. So I have x is greater than 2. So I have a point here at 2, it's open, and my line goes to the right. Then I have x is less than or equal to -1, so I have a closed point at -1, and my line goes to the left. It's an or statement, so I want all of my answers, so that's our final solution. So we solved the first inequality, we brought our joining word down, and then we solved the second inequality, and then graphed it just like we did yesterday as a compound inequality. Not terrible. Okay, let's try example number 2. This time we're going to do an and statement. So I have 7 times the quantity x minus 2 is greater than or equal to -7, and -3 times x plus 2 and then plus 8x is less than or equal to -1. I like to write these pretty spaced out, as you can see, so that when I cover things up to solve them, they're written far enough apart that I'm not getting confused and trying to solve things all together. Okay, so let's do this. First thing I'm going to do is distribute. So I have 7x minus 14 is greater than or equal to -7. I can add 14 to both sides. Those cancel, so I have 7x is greater than or equal to +7. Divide both sides by 7, and x is greater than or equal to 1. Now I'm going to bring down my joining word and write it here. And then I'm going to use my left hand to cover it up, and I'm going to go ahead and do the other side. So let's distribute. I get -3x minus 6 plus 8x is less than or equal to -1. I can add 6 to both sides. And then as I do that, I'm actually also going to combine my like terms. So the -3x and the +8x gives me 5x left on that side is less than or equal to +5. And then divide both sides. The 5's cancel, and I get x is less than or equal to 1. So that is my final solution, and this is a new special case for us to look at. So let's go ahead and graph this. I'm not going to make a very long number line, and you'll see why in just a minute. I'm going to put 1 in the middle and 2 and 0. Okay, so it's an and statement. I know I'm looking for where they overlap. So the first one, I have a closed point at 1, and my line goes to the right. Now the second one, I have a closed point at 1, and my line goes to the left. As I'm sure you can see, they only overlap in one spot, and that is at the point 1. So that is all we have. So my final solution for this problem is actually x equals 1, because there is only one number, only one solution that you can plug into these inequalities to make them true, and that is the number 1. Okay, I have the last example, arguably one of the more difficult ones, because this is dealing with compact form. So if you recall, compact form is when you have an and statement written without the word. So you have two inequality symbols, you've got your expression in the middle where your variable is, and it always has to be in the middle, and then you have your numbers on the left and right, with the smaller number on the left and the bigger number on the right. Now, when you solve this, I'm going to draw a line here and a line here, because normally when we solve these, there's only one symbol, there's only one equal sign, whatever. Now there's 3 sections. So anything we do to one section, we have to do to all of the sections. If I cover this up, and this was just 6x plus 9 is less than 21, we know what to do with that. We would subtract 9, then divide by 6. I'm going to do those exact same steps, but I have to do it to all 3 sections at the same time. So when I subtract by 9 in the middle, I'm also going to do 21 minus 9, and I'm going to do 3 minus 9. So left to right, 3 minus 9 is negative 6. Copy my symbol. The 9's cancel in the middle, and I'm just left with 6x. Copy my symbol. And 21 minus 9 gives me 12. Last step is to divide by 6, which means I'm going to divide negative 6 by 6, and I'm going to divide 12 by 6. So negative 6 divided by 6 is negative 1. Copy my sign. The 6's cancel in the middle, so I have an x. Copy my sign. 12 divided by 6 is 2. So underneath that, let me just rewrite it so you can see it better. It's negative 1 less than x less than 2. Or the other way we can read that is negative 1 is, or x is between negative 1 and 2. When we graph this, I'm going to put 0 in the middle. We'll do negative 1, negative 2, and then positive 1, positive 2. And then I have an open point at negative 1, an open point at 2, and a line between them. And that's it.